So picture this. It's May 9, 2026, 2 a.m. Universal Time. You're sitting inside a military A400M Atlas aircraft, and you are flying in just pitch darkness over the South Atlantic.
And it is not a quiet ride. The only sound is this deafening roar from 4 massive turboprop engines, plus, the howling wind just tearing at the outside of the fuselage.
Right, exactly. And inside this freezing cabin, just under these dim red lights, you've got 6 elite paratroopers and 2 medical personnel. And they're doing their final gear checks. They are about to step off the ramp into winds exceeding 40 kilometers an hour.
Which is terrifying.
Right. And their target is a rocky golf course on literally the most remote inhabited island on Earth. Why? Because a patient on the ground is running out of oxygen. And this absolute leap of faith is literally the only way to save it. So, welcome to today's deep dive.
Glad to be here.
Today we are unpacking a massive stack of sources. We've got UK Ministry of Defense tactical reports, World Health Organization, epidemiological data, and standard critical care transfer guidelines, all to explore this real-life medical thriller from May 2026, which is Operation Hantavirus.
Yeah, and it really is an incredible case study in extremes. I mean, in this deep dive, we're going to contrast 2 completely different worlds of medicine. On one hand, you have the highly controlled, very rigid environment of standard ICU patient transfers. And on the other, you have the absolute extreme edge of what we call austere medicine.
Right, where human survival completely depends on what you can basically strap to your body, throw out of an airplane, and then operate in the middle of a storm.
Exactly.
But before we can even understand why an intensive care unit is being dropped out of the sky, I think we have to look at the microscopic threat that forced this whole operation.
Yeah, the spark that lit the fire.
Right. So I want to transition away from that freezing military aircraft and dial back the clock about a month. We need to go to a luxury cruise ship.
Ah, right, the Dutch cruise ship, the MV Hondius. So on April 1st, 2026, it leaves Ushuaia, Argentina. And on board, you've got around 150 passengers from 23 different nations.
A really diverse group.
Yeah, and they are heading out on this expedition toward Antarctica.
And the sources indicate the index case. So the first person to actually get sick was a 70-year-old Dutch passenger.
Right. And the epidemiological data points to him contracting the virus before he even stepped foot on the ship, actually.
Wait, really? Before the cruise?
Yeah, he was likely exposed during a birdwatching trip in Patagonia. He probably came into contact with a wild, long-tailed Collie Largo rodent.
Oh, wow.
So 5 days into the Antarctic cruise, he starts showing symptoms. And at first, it just looks like a standard everyday bug, he has a fever, maybe some body aches, a stomach ache.
Just standard travel sickness stuff.
Exactly. But the deterioration is incredibly rapid. By April 11, he is dead.
God.
And then weeks later, his wife dies. In total, the outbreak on the MV Hondius results in 8 confirmed or probable cases and 3 deaths.
I'm just trying to picture how this actually spreads. Because if it requires close bodily contact, a cruise ship seems like kind of a strange place for a massive outbreak.
How so?
I mean, people have their own cabins, right? They aren't constantly touching each other. So how did it spread so effectively?
Well, you have to look at a cruise ship not just as a boat, but as a biological centrifuge.
A biological centrifuge.
Yes, it's a closed ecological loop. You have passengers and crew from 23 different countries sharing dining halls, narrow corridors, and crucially, ventilation spaces for weeks on end.
The shared air.
Right, and that proximity is exactly what the Andes virus needs.
Okay, the Andes virus, or ANDV. The sources mention this is a specific strain of hantavirus, but I always thought hantavirus was mostly something you get from, sweeping up an old dusty cabin and inhaling aerosolized mouse droppings.
Yeah, the classic Southwest U.S. scenario.
Right, and the person gets sick, but it's a dead end, like they don't pass it on to their family.
And for almost every hantavirus strain in the Americas, you are entirely correct. They cause hantavirus pulmonary syndrome, or HPS, and human-to-human transmission it doesn't happen.
Okay.
The human body is a dead end for the virus, but the Andes virus is the terrifying exception to that rule. It is the absolute only hantavirus strain in the world proven to transmit from human to human via close contact and bodily fluids.
And it boasts a staggering 30 to 50% mortality rate.
Which is astronomical when you compare it to most pathogens we encounter. I mean, think about the mortality rates we're used to seeing.
Right, usually it's fractions of a percent.
Exactly. But if we connect this to the bigger picture, the real danger of Andes virus isn't just that massive mortality rate, it's the incubation period.
Oh, because it takes a while to show up.
Yeah, it can be anywhere from 4 to 42 days.
42 days, that's over a month.
Right. And people are contagious when they show symptoms, but the sheer length of that incubation window means passengers can, pack their bags, disembark the ship, catch international flights, and just scatter a highly lethal pathogen across the globe before anyone even realizes they are harboring a virus.
So they scatter, and one passenger takes it somewhere you absolutely don't want a virus to go. Because the virus didn't just stay on the Hondius.
No, it didn't.
On April 14th, the ship made a stop, and it left the virus behind on literally the most isolated settlement on the planet, which is Tristan da Cunha.
Yeah, and the geography of this place really dictates the entire crisis. Tristan da Cunha is this volcanic island just smack in the middle of the South Atlantic Ocean.
Basically a rock in the ocean.
It really is. It has a total population of just 221 people, and they all live in a single village called Edinburgh of the Seven Seas.
And it has no airport, no landing strip whatsoever. The only way to get there is a 6-day boat journey from South Africa, which is over 2,800 kilometers away. And a British citizen who lives on the island, who had boarded the Hondius while it was docked just to assist with local logistics, he developed severe symptoms by late April.
Yeah, the timeline catches up to him.
The fever hits. Then the severe shortness of breath. Now, the island has a small clinic, the Kamogli Healthcare Center, but they only have 2 doctors.
Just 2.
0 ICU beds, 0 mechanical ventilators, and crucially, they have a severely limited supply of medical oxygen.
And to understand why that lack of oxygen is so critical, we really need to look at the pathophysiology of hantavirus pulmonary syndrome.
Right. What's actually happening inside the body.
Exactly. When the Andes virus attacks the body, it doesn't actually destroy the lung cells directly, which is what you might expect.
Okay, so what does it do?
It enters the endothelial cells. Those are the cells that line the inside of your blood vessels. And this triggers a massive, overwhelming immune response known as a cytokine storm.
Oh, a cytokine storm. Yeah. So the body basically overreacts to the point of destroying its own infrastructure.
Exactly. The immune system releases so many inflammatory proteins that it causes extreme vascular hyperpermeability.
Okay, vascular hyperpermeability.
In simple terms.
In simple terms, the blood vessels literally start to leak.
Wow.
Yeah. Plasma separates from the blood and just floods out of the vascular system, pouring directly into the alveolar sacs, which are the tiny air spaces in the lungs. So the patient develops non-cardiogenic pulmonary edema.
Wait, hold on, because this leads to a fascinating medical contradiction that I was really struggling with in the sources.
Oh, about the shock treatment.
Yes.
Yeah.
Usually in emergency medicine, if a patient is going into shock, meaning their blood pressure drops because they are losing fluid volume, the immediate response is to pump them full of IV fluids to get the pressure back up.
Right, you fill the tank back up.
Exactly. But the tactical medical reports explicitly state that giving this patient IV fluids is essentially a death sentence. Why is that?
Because of that vascular hyperpermeability we just talked about. Their blood vessels are leaking so badly it's like a completely porous hose.
Oh, I see. So any IV fluid you push into their veins, it just doesn't stay in their circulatory system. It pours straight through the leaky vessels and directly into their lungs.
So if you give them fluids to fix their blood pressure, they will literally drown from the inside out.
They drown from the inside out, yes.
That is horrifying. I mean, imagine you are one of the 2 doctors in that tiny island clinic. You know exactly what is killing your patient. You know the standard shock treatments will kill him faster.
And you're looking at your limited oxygen tanks.
Right. You realize you are doing math on a man's life.
It's terrifying.
Sure.
And the required protocol for this condition, it requires a very delicate medical tightrope. You have to enact extreme fluid restriction.
No fluids at all.
Basically none. To keep their blood pressure from crashing, you have to use vasopressor medications, like norepinephrine.
Which do what exactly?
They forcibly constrict the blood vessels, so you're squeezing the pipes to keep the pressure up without adding any new fluid volume.
Okay, makes sense.
But while you do that, you have to pump them with massive amounts of supplemental oxygen, just to keep their brain and organs alive. You're basically hoping you can buy enough time for those leaky vessels to heal themselves.
And normally, if you have a patient who is this critically ill, requiring that level of delicate, constant balancing, you transfer them to a major hospital.
Oh, absolutely. If you look at the source data outlining the guidance on the transfer of the critically ill adult, standard protocol dictates loading the patient into a CEN-compliant ambulance.
CN-compliant meaning?
It means it meets strict European standards for mobile intensive care. So you need a vehicle with an active power inverter, which is essentially a massive regulated battery system.
Right, to keep the machines running.
Exactly. It ensures high-tech life support machines run smoothly without any power surges. You need a fully equipped critical care trolley, securely mounted, mechanical ventilators, a perfectly temperature-controlled environment.
But maritime medevac is completely impossible here. I mean, even the closest Royal Navy ship, the HMS Medway, is days away.
Yeah, and you cannot put a patient who is actively drowning in his own plasma on a 6-day boat ride through rough Atlantic seas.
So you have a drowning patient, no oxygen, and literally no way to move him. That leaves only one option: bring in the hospital to the island.
Which sounds impossible.
Right, because how do you do that when the nearest runway is thousands of kilometers away?
You drop the hospital out of the sky,
Ooh.
which kicks off a 56-hour logistical nightmare. The British military realizes the situation and greenlights an operation. They have exactly 56 hours from that moment to get boots on the ground.
And they're covering a distance of 9,788 kilometers from the UK down to Tristan da Cunha.
The sheer distance alone is just mind-boggling. The Royal Air Force deploys an A400M Atlas transport plane from Oxfordshire.
But this plane has to fly so incredibly far down the Atlantic that it physically cannot carry enough fuel to make the trip, loiter over the drop zone, and then get to a safe landing strip afterward.
Right, so they have to execute mid-air refueling.
Yeah.
An RAF Voyager aircraft is deployed to meet the A400M over the ocean.
And keep in mind, you, the listener, you're doing this over the open Atlantic, in pitch darkness, matching speeds while essentially threading a fuel hose into a probe on the Atlas.
It's incredibly dangerous.
It requires absolute precision from the pilots just to ensure the plane actually reaches the airspace above the island.
And then there's the payload inside. Let's talk about the team they put together. You have 6 Pathfinder paratroopers from the 16 Air Assault Brigade.
The lead of the elite.
Oh yeah, these are elite soldiers, highly trained for high-altitude, high-risk jumps in terrible weather. But paratroopers aren't doctors.
No, they're not.
You need people who can actually analyze the patient's blood gas and administer those vasopressors once they hit the ground.
So to solve that, they brought in an RAF ICU consultant and an Army ICU nurse. They have the medical expertise to save the patient, but they do not have the training to conduct a tactical free fall into an active storm.
Not at all.
Are you saying the doctors had to jump out of the plane physically strapped to the soldiers? Like, how do you even practice that?
You don't, really? Not for a scenario like this. They had to perform tandem jumps. The medical personnel are physically harnessed to the front of the elite Pathfinders.
That is wild.
The doctors essentially have to surrender all control. They just have to hang on, trust the soldiers strapped to their back, and pray their hands are steady enough to push delicate intravenous medications the second their boots hit the grass.
I really want you to try and put yourself in the shoes of that ICU nurse. You spend your whole career in brightly lit, completely sterile hospitals with perfectly regulated power.
Right.
And now you're standing on the edge of an open aircraft ramp, staring down in the black clouds over the roaring South Atlantic, just waiting to be pushed out.
It's unthinkable. And dropping the medics is only part of the equation, right? Because a doctor is useless without their tools. The military also had to drop 3.3 tons of medical gear. And crucially, this included the highly pressurized oxygen tanks that the island clinic desperately needed to keep the patient alive.
Now, dropping pressurized oxygen tanks from a plane sounds like dropping unpinned grenades.
It really does.
If they hit the ground too hard, wouldn't the valves snap or the tanks just simply explode?
They absolutely would, which is why the military utilized a container delivery system, or CDS.
Okay, CDS. How does that work?
Well, to prevent a catastrophic explosion on impact, they couldn't just throw the boxes out the back. The oxygen tanks were packed into heavily reinforced pallets.
Okay.
And the base of these pallets was rigged with specialized honeycomb crush materials. It's this rigid cardboard structure designed to crumple and absorb the massive kinetic shock of hitting the earth.
Oh, that's smart.
Yeah, and they also attached multiple massive cargo parachutes to severely slow the descent rate. It had to be a perfectly choreographed sequence of timing and physics just to ensure the gear landed intact.
Dropping the gear safely is one thing. Landing the humans safely in a storm is another. Which brings us right back to that dark plane over the Atlantic. They reached the drop zone, the ramp opens.
And the conditions are atrocious. They were dropping into a geographic region historically known by sailors as the Roaring Forties.
Sounds ominous.
It is. It's a latitude notorious for wild, unpredictable weather and baseline winds routinely exceeding 40 kilometers per hour.
The tactical reports detail the mechanics of this jump, and it is fascinating. The paratroopers couldn't just float down.
Right, because of the wind.
Exactly. When you deploy a ram air parachute, the rectangular ones they use, it acts like an airplane wing. It generates forward speed.
Yep.
So if you are flying forward and you have a 40-kilometer-per-hour wind pushing you from behind, you will just slam into the ground or get blown straight out into the jagged ocean cliffs.
So the paratroopers have to use their steering toggles to immediately turn their parachutes to face directly into the gale force winds.
Okay, facing the wind.
By flying into the wind, they use the wind speed to cancel out their parachute's forward speed.
Right.
So relative to the air, they are flying forward. But relative to the ground below them, they were literally flying backward through the cloud cover.
Flying backward. And one of the paratroopers later described navigating backward through the clouds to land on a tiny rocky golf course as a, quote, pretty tasty jump.
Which I think is just peak British military understatement for absolutely terrifying.
Right. But they make it. They hit the ground, they detach from the harnesses, unpack the honeycomb-rigged oxygen tanks, and rush to the clinic.
And this is where the reality of prolonged field care begins. All those CEN-compliant ICU standards we talked about earlier,
Gone.
completely gone. They are now practicing austere medicine.
What does that actually look like in practice?
Yeah.
I mean, what does it mean to manually titrate oxygen?
So in a modern ICU, you have a mechanical ventilator constantly reading the patient's blood oxygen levels and automatically adjusting the flow, breath by breath.
It's all computerized.
It's precise, automated, and backed up by digital alarms. On Tristan da Cunha, manually titrating oxygen means the ICU nurse and consultant are standing over the patient, physically turning the dials on the oxygen tanks by hand.
Wow.
Yeah, constantly monitoring the patient's vitals and adjusting the flow second by second to ensure they don't waste a single drop of the oxygen they just pulled out of the sky.
All while maintaining that delicate vasopressor drip to keep his blood vessels from leaking faster. It is incredible. But while those two medics are on a rocky island fighting for one man's life, the rest of the world is scrambling to contain the broader fallout of the MV Hondius.
Right, because remember that ship was a biological centrifuge and it's finally docking in Tenerife.
Right, the cruise is over.
Yeah, and now you have the World Health Organization and 19 different nations trying to execute a mass repatriation of 94 potentially infected passengers.
And because of the virus's long incubation period, these people could be ticking biological bombs. You can't just buy them a ticket on a commercial airline.
Absolutely not. Global health authorities treat the Andes virus with BSL-3 protocols.
BSL-3, what does that mean?
That stands for Biosafety Level 3, which is a designation for microbes that can cause serious or potentially lethal disease through respiratory transmission.
Okay.
So because of that BSL-3 potential, passengers are flown home under incredibly strict biosecurity measures. Some countries deploy specialized military airframes. Others use chartered flights outfitted with high-level containment transport protocols.
Meaning what exactly?
Meaning negative pressure isolation pods and flight crews in full hazmat gear.
Oh wow, full outbreak mode.
Exactly.
And it doesn't end when they land, either. Because once these passengers get back to their home countries, they are subjected to a mandatory 45-day quarantine just to outlast the virus's maximum incubation period.
It's an incredible contrast. I mean, think about it. You have this massive, highly coordinated international biosecurity dragnet operating with cutting-edge containment plans. Happening at the exact same moment, two medics are manually turning an oxygen dial in a volcanic island clinic.
Yeah, when we step back and look at the whole picture, we have a 56-hour military operation covering nearly 10,000 kilometers.
Insane.
It required mid-air refueling in the dark, a tandem parachute drop into a storm where elite soldiers flew backward to hit a tiny target, all to manually combat a virus with a 50% mortality rate.
It's a movie.
It really is. And this operation proves that airdrop medical insertion isn't just some theoretical whiteboard exercise anymore. It is the absolute new frontier of global health security and military medicine.
It completely redefines what we consider a deployable capability. It proves that when extreme distance and impossible geography make traditional medevac completely useless, we still have the ability to project highly specialized critical care directly to the point of need.
So the human expertise and the equipment.
Exactly, both the nuanced human expertise and the heavy, delicate equipment.
I really want you to think about the sheer, crushing isolation of being on Tristan da Cunha. You are days away from the rest of the world. Your lungs are filling with fluid, your oxygen tanks are running empty, and then you hear the drone of an engine in the storm. You look up and you see parachutes breaking through the clouds, dropping the exact molecules of air you need to survive. It sounds like science fiction, but it was a very real Tuesday for these teams.
It is a phenomenal achievement. But, you know, if we connect this to the bigger picture, it raises an incredibly important question about our future.
Oh, how so?
Well, as climate change shifts animal habitats, and as the ecotourism industry pushes human beings deeper into untouched, isolated environments.
Like the bird watching in Patagonia.
Right, or taking luxury cruises to the Antarctic. Our exposure to novel, highly lethal pathogens is only going to increase.
That's a good point.
So if the next pandemic starts on an isolated island or on a ship in the middle of nowhere, will we always have the incredible, overwhelming military resources to drop an ICU out of the sky? Or does this event prove that our global medical infrastructure needs a radical, fundamental redesign to survive the future?
That is a chilling thought, and definitely something to chew on the next time you book a remote, off-the-grid getaway. But that's all the time we have for today's dive into Operation Hantavirus. Stay curious.